Guys, I just wanted to talk to you about digestion and put a more visual slant on it. Excuse me. And this is from eChalk. And so hopefully what you can see now is the picture of the alimentary canal, and you can see what's on my screen. So, for example, obviously we've got the mouth, and that goes down to the esophagus, and that comes down to the stomach, okay, and then that comes down to the small intestine, and then into the large intestine. And remember I said in one of my videos that the liver and the pancreas looked with the shapes they had. The liver is really big, it's the biggest organ outside the skin, I believe. And then the pancreas looks, I described it like a Roman emperor's crown leaf. So now we had that in that question. This is the gallbladder here, and the gallbladder is the thing that stores the bile, which you can see is squirted into the small intestine here. So can you see the pancreas there and the gallbladder lead into the small intestine, and that's where the enzymes, pancreatic enzymes of the pancreas get squirted in, and then from the gallbladder, liver produces bile, which goes into the gallbladder and then in. Okay, so now this is eChalk, which is just based upon the scientific resources which are available on this website. What you need to do is you need to, the username is Rygate and the password is master, and you can look at a number of quite cool things to explain a number of processes. So it says click on here to explain more, and so if I wanted to click on here the esophagus, it would just show that it has muscles in its walls. These muscles contract behind the food to push it along towards the stomach. This type of wave muscle contraction is called peristalsis. Okay. Stomach. Food enters the stomach through a ring of muscle known as sphincter. That's not something that we've actually discussed, but all of the gateways to each of the areas is called a sphincter, which finishes actually with your anus, which has an anal sphincter, which you might have heard of. Now remember that the stomach contracts and it's kind of liquefying that food, and you can see there that it's called chyme. Okay, it says in the text there, here the food is mixed with stomach acid so that protein digesting enzymes, proteases, you know that is pepsin, which is a protease, have the correct pH to work efficiently. Okay, and the stomach acid also kills bacteria that are ingested with the food. The other thing, which I've just mentioned to James, in fact, in an email, is that bacteria are going to be in your stomach because in your other part of your throat is your trachea, which leads down to your lungs. And all along your trachea and in your bronchi is mucus, which traps bacteria and dust and any nasties which you might breathe in. Remember, when you breathe in, you are in fact breathing in air which you can't control what's in there. It's why you might get poisoned if a poison gas was in the vicinity, because you can't control that. All you can do is trap those things which might get in the way of your lung surface area. And so that tends to be dust and bacteria and things which naturally stick to your mucus. You then have these tiny hair-like projections. They're not hairs, don't call them hairs, but they're hair-like projections that waft the mucus back up your throat, and then you can feel it when you swallow, that you're actually swallowing mucus. And that mucus will contain in it bacteria and pathogens and dust, which can go into those really horrible, inhospitable, acidic conditions of the stomach and get killed. So that cross-references nicely to the immune system, the way that your body prevents things getting into it. It also cross-references to smoking, because it's the cilia that are damaged by smoking. And that means that you can't clear the mucus back up your throat. The mucus is carried by these cilia, C-I-L-I-A, like a conveyor belt. And if the conveyor belt stops working, then your mucus can't be pushed back up to the top of your throat and swallowed. And therefore, instead of, in fact, creating a conveyor belt which gets rid of the bacteria and the pathogens by swallowing them, you actually do the opposite. You create a moist, warm environment with the mucus not being moved, in which bacteria can, in fact, multiply. So that cross-references to cilia and the damages of smoking, and that's why you cough. And in fact, you don't have to have your cilia damaged to start coughing. If you've got a build-up of mucus in your throat, that's when you cough, because you're not clearing it. The other thing smoking can do is cause these cells called goblet cells to secrete more mucus, and therefore it has a build-up which causes the smoker's cough as well. Okay, so going on to the small intestine itself. Now, interesting, remember we had that question in the paper recently, and it said, where is peristalsis taking place? And it gave you an option of A, B, C, D, and E. Remember, it was all of them. It's very obvious in the throat, because you can feel the food going down. But do you think it's just magic? I suppose it could be gravity, which takes it all the way down to the anus. But you can digest food when you're lying down. And so it is peristalsis which pushes the food all the way through the gut, all the way out of the anus, these smooth muscle contractions, a bit like squeezing a sausage. Okay. Now, this talks about the intestine being made up of duodenum and ileum. Okay. Talks about bile. And emulsification is the breakdown of those fats into tiny droplets, which increase the surface area for enzyme tag. Okay. When we go into the large intestine, colon, appendix, and rectum. I like this detail actually. By the time food gets to the colon, digestible foods have been broken down and absorbed into the body. Remember, digestion is breaking down of large insoluble molecules into small soluble ones. And only the undigested material, things like cellulose and fibre, remain, and then water is reabsorbed into the blood in the large intestine. Remember, the movement of water is usually, in fact, I can't remember the time, it's not, is osmosis. Okay, the movement of water from an area of high water potential to low water potential, which is effectively just the same as a water potential gradient, and it will be going through a semi-permeable membrane over 3 points of osmosis. Just to finish this off, you've got the liver, which produces the bile, and there you can see the term emulsification, and you can see that gallbladder, and then the pancreas produces the pancreatic juice. And that's quite a nice term, in fact, because that encompasses all of the enzymes that the pancreas produces, and specifically amylase, lipase, and protease. And remember to mention that it's pancreatic amylase and not to be confused with the amylase in the mouth. Pancreatic lipase and pancreatic proteases. Okay, the pancreatic protease is something like trypsin, Trypsin. Just if you wanted to name one. And remember, under Rackham's rules, we're always looking to name things. In a mark scheme, it might say protease and then another mark for named protease. So if you might get 2 marks for saying pancreatic protease trypsin. Okay, so that is the intestine with a visual description. Please look at my other video. I'm going to forward you an email that I've just sent to James Rackham, who's been doing brilliantly in trying to nail this. And I've added a few things which talk about what I've just talked about there. Okay, so keep working hard, guys. I'm really proud of the effort, as I've said before, and you can really do special things here.